All right, here's question number 7. Let's see what it says. In this question, I and j are horizontal unit vectors. Okay, so this is a question about vectors, velocity vectors. Let's see what it says. At midnight, a ship S is at the point with position vector. All right, the ship travels with constant velocity. So we're given the constant velocity in vector form. And in the first part, we're supposed to find out the speed. Okay, so that's a no-brainer. Speed is always the magnitude of the velocity vector. So speed is equals to square root of 12 squared plus minus 16 squared. So use your calculator over here. This is going to be 144 plus 16 squared. What's that? 256, and that's equal to 400, square root of which is equals to 20. Is it kilometer per hour? Yeah, kilometer per hour. Okay, now part B. Part B says, at time t hours after midnight, the position vector of S is s kilometers. Find an expression for S in terms of I, J, and T. Okay, so the ship is starting from a point of which we know the position vector, and we know that this is the constant velocity at which it's moving every hour, and we're supposed to write down the position vector at any point in time. Okay, so the way it works is it's kind of like the equation of a straight line, y equals to mx plus c. So A is the position vector at t0 or the starting point plus the velocity, which is kind of like the gradient, okay, multiplied by the time. So this is the standard equation that we're going to use. So S is equals to 1922, the starting point. Okay, so we're going to write it in column vector. You can write it in ij form. The question says ij, so we better do it in ij, plus v, so that's 12 and minus 16 t. Okay, so we have 19 I plus 12 I times t plus 22 j minus minus 16 j times t. Okay, now you can write this nicely. You can write this as 19 plus 12 t times I, okay, and then 22 minus 16 t times j. There you go. Okay, so easy marks. Now let's have a look at part C. Part C says, and this by the way is S. Part C says a lighthouse stands on a small rocky island. The lighthouse is modeled as being the point with position vector so and so. It is not safe for ships to be within 1.3 kilometers of the lighthouse. Okay, see part 1. Find the value of t when S is closest to the lighthouse. Okay, so we're supposed to find out the value of t when S is the closest to the lighthouse. Okay, so that means the distance is as minimum as possible. So here's OS, okay, which is basically the position vector of the ship at time t. So 1922 plus 12 and minus 16 times t. And then OL, which is basically the position vector of the lighthouse. Now, obviously, the lighthouse is stationary, it's not moving anywhere, so it's just going to stay where it is. There is no speed multiplied by, there's no velocity multiplied by time. Now, if I want to find out how far away they are, all I have to do is subtract the two vectors. Now, you can subtract them in any order, okay, because how far away is the lighthouse from the ship is the same as how far away the ship is from the lighthouse. Okay, so if you do the position vector of ship minus the position vector of the lighthouse, you will get LS. So let's do that. So we have 19, 22. Let's just copy paste it to save time. So this, okay, let's copy this. Okay, I don't think we're saving time, but anyway. Okay, this is not what I copied. In fact, you know what, never mind, let's just write it again. So 1922 plus 12 minus 16 times t, and from this, what are we subtracting? We're subtracting 26 and 15. Okay, so all we have to do is basically 19 minus 26. So what's that equal to? That's equal to negative 7. Okay, and then 22 minus 15, that's also equal to 7. So minus 7, 7 plus 12 and minus 16 times t. This is basically LS. Now, if I want to find out the distance will basically be the magnitude. Okay, this is the displacement in vector form, in ij form. But if I want to find out the distance, that means I have to find out the magnitude of this vector, which means doing minus 7 plus 12t, the whole thing square, plus 7 minus 16t, the whole thing square. And don't lose track of the question. The question is asking us to find out the value of t when S is the closest to the lighthouse. So this is basically the way to find out the distance. Okay. Now you're probably wondering why we're doing this. There's no way that we can equate it to something and find out what the value of t is. And you're right, you're absolutely right, but you will see what I'm up to in a minute. So, okay, just realize this should not be to the power of t, this should be the whole thing squared. Now we expand this and we get 144 t square, okay, minus 168t using the second identity plus 49, and then once we expand this we get 49 minus 224t plus 256t squared. Okay, all this inside the square root. Now 144 plus 256t squared, that's going to be equal to 400t squared minus 392t plus 98. This is inside the square root. Now you're probably wondering, how exactly am I going to solve this? Well, we're not going to solve this. Okay, we're not going to solve this. What we have to do is we have to find out the value of t when the distance is the least. Okay, distance is least, meaning that the ship is closest to the lighthouse. So how can I find out the least possible value of this function? Okay, if we ignore the square root for a minute, how do we find out the least possible value of this? Well, if you think about it, what is this? This is a quadratic function. Okay, and since this is a quadratic function, meaning this will give us a quadratic curve, a minimum curve. Okay, and what we are supposed to find out is basically the minimum value of the curve, and not just the minimum value of the curve, we're supposed to find out the value of t at which the value of this curve is minimum. Okay, and how do we do that? We don't have to use anything to do with vectors, we can just use differentiation. Okay, so let's say that this is the distance, let's call this x. Okay, so x is the distance. So what we're going to do is we're going to do dx upon dt. So that would be equal to 800t minus 392, and since I want to find out the coordinates of the turning point, because the turning point is the stationary point which is also the minimum point, I need to equate this to 0. So 800t minus 392 is equals to 0, and then simply solve for the value of t, you will get 0.49. Okay, so this is the value of t when it is the closest. How do I know that this is the value of t when it's the closest? Because this is the time when the curve is turning, and the curve is turning means it's the minimum value. And what value is it representing? It's representing the distance. Okay, so what we have done here is we are basically finding the minimum value by differentiation. Okay, and this curve that I've drawn, this was for your understanding. You don't have to do this in the exam, but if you think this will help you understand it better, then go ahead. Okay, so t is equals to 0.49 is the answer to the first part. Let's see what the second part says. Hence determine whether it is safe for s to continue its course. So that means we found out the value of t when the distance is minimum, but what we haven't found yet is what is the minimum distance? What is the minimum distance that it will ever reach? And the way to do that is by simply plugging in this back into the equation. That means 400 into 0.49 squared minus 392 into 0.49 plus 98. Okay, and this will give us the distance between the lighthouse and the ship. So the distance between the lighthouse and the ship, the magnitude is equals to square root of 1.96. Okay, use your calculator to work out the above. And you will then have the minimum distance, which is square root of 1.96, which is 1.4. And because 1.4 is greater than the minimum distance that it should be, the least safe distance, therefore it is safe to continue. Okay, so because 1.4 is greater than 1.3, so it is safe to continue, because the closest that it will get to the lighthouse is 1.4 kilometers. Okay, and according to the question, 1.3 is the closest it should get, and because the closest distance it will ever get is more than the safety distance, therefore it's safe to continue. So interesting question, and I haven't seen many of those many questions where you have to sort of differentiate and find out the value of t or the distance. So, but again, it's all about how well you understand not just vectors, but how well you understand differentiation, how well you understand quadratic curves. So if all that understanding is intact, then you will be able to solve questions like these, inshallah. Okay, now let's move to the next question.